Setting up. I just wanted to show that how people who found out a lot of failures can still come and give a keynote in front of you people. So this is mainly about some lessons as well as some insights about how to work in the sustainability. So this is a very young me sitting in Delhi College of Engineering. In the middle, I hope you realize it's me. Sitting with the plane. So this was an autonomous aerial vehicle which we were trying to build. We went to the US. That was my first flight directly to the US. This was a competition called AUVSI. This is in the US, so we got covered in the news. This was the first team from Asia who went to the competition, and our plane didn't fly. So we got the best effort award because we kept trying to get the plane to fly, but it didn't work. And there were teams for the previous 15 years who had been coming every year who were flying autonomously. So this is the software which I built for the ground control station. Right. So this is the software which gets you keynotes. If you're trying to get into keynote into academic conferences, it's horrible. Right. So this was the level of software. This is the level of code which I wrote back then. I now teach Introduction to Programming in various courses. This is perhaps an example of how not to write code. Use arrays, don't use globals, etc. Poor code, right? And what happened to version control? This was my version control system. File underscore 1.py, 2.py, 3.py, final.py, finally final.py, finally final.py. Right? So at this point, I thought I was into research. To be honest, I don't know whether I was or not, but I was very excited about engineering. I wanted to build stuff, and the people I've drawn some bounding boxes, all of them went outside for studies. I felt I was also cut out for studies outside, but due to some family reasons, I chose not to. And then I felt that maybe it's a missed opportunity. Should I have done something else? I went on and joined a software engineering job and got bored to hell. So got bored to death. The only thing which I did there in that company was to just drink some juices. I didn't do any productive work. 6 months later, I decided I should do a PhD or figure out something. I just wanted to point out this particular thing. This is something recently I read in a book, 1,000 Things People Do Well, something like that. So I felt it was a missed opportunity, but it was also an opportunity from that point onwards to start afresh. I decided to find out places where I can do some higher studies in India. And I was very, very naive. So for the people who are not well versed with the Indian academic system, we have colleges which are typically known for good research called Indian Institute of Technology. So I didn't apply to them. I felt they were doing very poor work. Again, a very, very poor assumption. I just felt that research in India is okayish. The only good research happens in the West. IITs are only good for bachelors, they are poor for PhDs and higher studies. And the exams, the entrance exams for these are also very poor. So again, these were very, very unresearch-like behavior that I exhibited at that point of time. I hope that the audience is much, much smarter. They're sitting here. So first lesson which I wanted to share with all of you is to test your biases. Not have any stupid newspaper-based opinion of certain colleges of certain degrees. Spend some time, figure out what you want to do, where you want to do. I then wrote to a faculty, so I did my PhD from this college itself. So I wrote to a faculty, I went for a PhD interview and I was rejected. I was caught in the sense that my knowledge was lacking. I was thinking that I had a lot of background, a lot of good research done, but in my first interview I realized that I had zero research done. I only knew to write some pieces of code, which was also horrible as you've seen. But this was an eye-opener, and I really liked the fact that there was someone who could expose me, who could teach me something. So then I joined the PhD program under him, which was the next lesson. You should be choosing your advisors very carefully. I was lucky that I got a good advisor. I didn't spend a lot of time, but you should be spending some time at least in choosing in choosing your PhD advisor. It's like a mini marriage. Many cases, it's useful to do some kind of research assistantship under them for some time. So this is start of the PhD work. This is a very inspiring photo. Does anyone recognize this photo? Right. So again, this for the people who are from outside, yes, for who might not have seen this Indian Bollywood movie, This is from a movie called Swadesh, We the People. This is the story of an Indian scientist who returns from NASA, Indian origin scientist who returns from NASA to do some wonderful things in India. This picture is showing an old lady who's seen the electricity for the first time in her life. So this was very inspiring for me when I was a 13, 14-year-old kid. I wanted to do something similar. So therefore, this was working out well. I was joining a PhD program where the faculty was also working on building energy consumption, on energy, etc. So we started to work on building energy because my advisor had a grant on it. Although I had all this background story, but if my advisor didn't have a grant, I would have probably worked on something else. So buildings consume significant amount of energy, and if we can make a dent here, we can reduce the overall energy consumption. So there are various ways in which you can reduce the energy consumption of buildings. You can construct buildings from scratch. You can do a bunch of retrofitting, like replace all of these lights with more efficient lights. But most of the buildings are already built. Most of the equipment which will be there for the next 5, 10, 15 years already exists. So what do we do? One key idea was to change the behavior of the occupants who are using the buildings. Can you incentivize them to reduce the energy consumption? So there's a very interesting survey which was done a few years back. People were given feedback as to what might help reduce energy consumption. One, it will reduce your carbon impact. Second, it will reduce the number of trees being cut. Third, it will lead to reduction in X dollars USD or X rupees consumed in your monthly bills. Which of them do you think work the best? Third one? Okay. Any other guesses? Interestingly, the one which worked the best was your neighbor is consuming lesser than you. No other feedback was given. Nothing specific was told as to what is causing them to use lesser energy, but that was sufficient. So the key point being that we can leverage behavioral economics. We can leverage the fact that people are social animals to reduce their energy consumption. So at this point of time, I started working on systems to collect sensor data, building energy data, various kinds of smart meters, various kinds of occupancy sensors, all the kinds of sensors which you can use to inform about energy consumption patterns. So we had this paper in 2012 in a conference called ACM Compass. But I've realized at this point that I was perhaps getting bored by just building systems. I wanted to do some actionable intelligence. This is also around the time when Andrew Yang released the first MOOC, which was a machine learning MOOC, and that is how I got started into machine learning. So one interesting problem which I found during reading during my PhD days is called energy breakdown. So imagine that instead of your monthly electricity bill or your bill, I tell how much each appliance is consuming. This is similar to when you go to a grocery store. Instead of just the total bill, I tell you how much each specific item was costing, and then you can go back and realize that maybe I can cut these XYZ things to save some amount of, to save some money. So there were some previous studies which suggested that this can help save up to 15% energy, and so I thought that let's talk about this. Let's see what we can do in this area. The simplest way to get this energy breakdown or to get the per appliance energy is to put a sensor on each appliance. Now, I did a home deployment. There is no prize for guessing that this is my home. The only way I was able to convince my family to put the 67 sensors and computers in my home was, this will help me graduate sooner. That didn't happen, but at least I got the deployment done. It turned out that while we may think that sensing in homes is easy, perhaps easier than when you have to install some sensor on the Swiss Alps, but even at homes this is very difficult. So if you can put these sensors, but if you are brooming, you may just accidentally end up disconnecting one wire. This is the beautiful nightlight view which I had in my room when I was sleeping. Routers and single board computers. Clearly not a very good, not a very good sleep. Interestingly, homes have very poor connectivity. So you are probably thinking of your sofa or your living room, but think at the places where your refrigerator is installed or your washing machine is installed. If you want to get the energy consumption of those, you need the Wi-Fi signal there. And we found out that homes have poor connectivity. It doesn't reach the places which are slightly remote in the home. So we did a bunch of electricity monitoring at different levels, smart meter, circuit breaker, appliance level. I'll skip some of those things. So as a result of this deployment, there were a lot of interesting things which we found out. One was the interquartile spread in the energy consumption or the voltage fluctuation in India was significantly higher than in the other countries in the West. So which meant that if you had to measure the consumption, energy consumption in India, you not only have to measure the voltage, but also not only have to measure the current, but also the voltage. I'll skip some of these details. The second lesson which I had at this point is that you want to be collecting data if you can, build some baseline systems. Now this is not only true for this kind of a study where you have actually got some sensors, but even for other kinds of studies. So the article that I'm showing is from Andrus Karpathy. Some of you might know him. He's a very well-known researcher in the AI ML community. So the ImageNet challenge, which led to a lot of improvement in the machine learning, deep learning sphere, there he did something known as the human baseline. If you were to give the human beings this data set for classifying across these 10,000 or 1,000, whatever number of categories, how well would a human being fare? So this kind of an exercise helps you understand your data really well. Are there images which you cannot identify? Are there images which the machine identifies but are wrong labels, etc.? So this is a lesson which I learned, that if you build systems, if you collect the data on your own, you get a much better understanding of the domain. So at this point, we figured out that we cannot install a sensor on each appliance. So we instead looked at something known as non-intrusive load monitoring. It has to be non-intrusive, so you cannot put a sensor on each appliance. And so the way this is typically done is, you have a smart meter, which is a single sensor per home. You get the power consumption from this smart sensor, or smart meter. You use machine learning to break it down into different components. This works because different appliances exhibit different kinds of signatures. Like the fans have a different signature as opposed to the AC, as opposed to your lights. Now, this is a very old field. This field started about 10 years before I was born. And I got very excited about this field reading some research papers and reading some blogs of my compatriots around that time. So there are a few blogs which I read which got me excited, which made research much more accessible to me. So what I wanted to share was that accessibility in getting your research more accessible usually helps. The other people get excited about your research. There's one thing to have a PDF published. It's another to have an accessible article written or accessible talk, which can cater to a different kind of an audience. So till this date, I maintain a blog, technical blog. Any guesses as to who reads this blog the most? So I read my blog the most. So therefore, even though I write it for the public, I end up revisiting my blogs again and again, because these are things which I found out. I don't have to search on Stack Overflow now. So then we looked into this problem of non-intrusive load monitoring. This was about 1.5 to 2 years into my PhD. And I got this very nice advice from a top researcher, more than 100,000 citations. This field is dead, not a good area to work in. And yet, crazy as I was, I decided to go and work in this area because I felt excited about it. There was a community, small community around it. So then I realized that when I was working in this area was that this research was not comparable. There were dozens of papers which kept on publishing better algorithms, but they were on different data sets, different algorithms, different subsets, different metrics, etc. You can't really compare. You couldn't do an apples to apples comparison. So that's where I made this first contribution, as to create this toolkit for NLM, which prepares the data in a common format, prepares some benchmark algorithms, provides a suite of metrics. Typically, you would call this as engineering effort, not as research effort. But I really got to leverage this later on in my PhD. And I was really excited about doing this at that point of time. Now, this got me the maximum citations amongst the other papers which I have. Now, citations does not equal impact, But I just wanted to say that this was something which was well recognized by the community. And after 8 years of having done this project, I got an email from one person who's working in the industry. Now, I've been working with them for some time now, and we're planning to scale this to million plus homes. They have access to million plus homes where we can deploy this technology. Right? The lesson for me here was that we should be taking all advice with a grain of salt. All well-intentioned advice, including mine, might not fit to your criteria, might not fit to your case. And end of the day, it's your PhD, it's your master's, it's your bachelor's, it's your degree. And so this is something which my advisor told, that if my advisor, if he decided everything I did, I had to do, then it's his PhD, not mine. The other lesson was that reproducibility and tools go a long way. Initially, there's a lot of effort, but then you understand the intrinsics of the problem statement much better. And impact takes time. Unfortunately, sometimes we may read some Twitter article. There was one Twitter article doing the rounds of someone who published 13 papers during their postdoc, something like that. Right? So I just wanted to emphasize that let's not run after numbers that much. Let's understand that impact may time. Sometimes you get lucky, sometimes it takes more time. All of us are attending conferences. So this is now about 2 years into my PhD. I was going to attend this conference, ACM Builds This. Many of you have also published there. I honestly went to this conference with a single objective. I wanted to find a good person with whom I could do an internship. I was looking for a few people, and I found out someone with whom I felt that the work was a good fit. I went with a single objective. I met that person. I spoke with him in detail. That is coming White House. Eventually, I was lucky that he offered me an internship role, and I joined that lab. So in terms of other, if we want to attend conferences, I also wanted to give an example of someone I saw recently who works in computer vision. So this person created a GitHub repository of the papers and the summary of some of the papers he was planning to attend. Not attended, planning to attend. Right? So what I've been telling my students also here is that figure out a few people in the conference whom you want to meet. Go outside your comfort zone. Meet a few people who you have never met before. But unfortunately, they were all sitting with me today again at the lunch table. Hopefully, they'll now hear me again. So the lesson is to find people and talks you want to attend, and say hi to people before the conference, after the conference, during the conference, to just keep the momentum going. It got me my internship and changed the track of my PhD very positively. The PhD crisis happens to some, may not happen to all. So this was a period where I kept submitting papers, kept getting rejected. And again, I many times during my PhD felt that I should drop out of my PhD. Right? So I just wanted to normalize this kind of feeling that rejection is common in academia. Now I've been on the other side also. I have seen papers getting rejected because the reviewer didn't spend 5 minutes on it. I've also seen some of my best papers have been rejected, some of my worst papers have been accepted, won some awards. Right? So there is a lot of randomness to the process. I just wanted to emphasize this fact that there may be some period in your PhD where things don't go your way. It would be good to have some people who will always be there with you outside this PhD work. I typically tell my students to have some hobby outside of work. I don't know, they'll tell you the truth whether I still load them enough that they don't get to exercise that hobby or not. But it's good to have some hobbies outside of work which are much more deterministic. So I very recently read an article from Cal Newport, who's the author of the book Deep Work. He had this very interesting podcast, and he had this interesting question there, that how do you define a productive day as a researcher? And what happens is that some days some people keep going in circles reading papers. So he mentioned very nice 3 points. Take notes so that once you have read few papers, you don't go to bed thinking that today was a waste. You at least have some artifact, something written down, which is a proof that you did something today. Seek help if needed. He mentions, at his level also he mentioned that if he goes some X number of days without making any progress, he reaches out to collaborators and then develop tools for it. So I kept working. In fact, at one point of time, I spoke to my postdoc mentor and I told him, I think I'm perhaps not cut out for research. I am not getting any results. And he looked at me in a very shocked face. He said, every week you're coming up with very good results and analysis. So I think having very supportive people is very important in the PhD. In fact, many people might say that don't just go for people who have dozens of papers, go for people who will support you. Right? So therefore, my earlier point on talking to people, understanding the relationship that you can form with a particular advisor is important, beyond just what the externals may suggest. So after this, I kept submitting, kept getting rejected. But fortunately, there came a phase where there were a lot of paper acceptances. So this was a work on scalable energy breakdown. Here the idea was that can I just use a monthly bill, not a smart meter data, to give you an energy breakdown. Again, I think the details are perhaps boring and we'll not have the time to go through all of them. But the important thing was, previously we were looking at individual households, 1 home, 3 homes, 5 homes. We were looking at that scale. But then we thought that can we give for each and every building in the world? Right? So we posed this as a challenge. Of course, we were not going to be able to solve it. We called it the Billion Building Challenge, which is roughly what we thought the ballpark, the number of buildings in the world. Can we give an energy breakdown for a billion buildings? So that scale really helped us to think as to what would be the input sources which would work across a billion buildings. It won't be billion smart meters anytime soon. It had to be the monthly bill. I'll skip all of these. Sorry, keep the questions coming if you have. So the important learning here was to think about scale, which will help you identify the right kind of assumptions as to what kind of sensing equipment can you use. At this point of time, I had published enough. I was happy to finish my PhD. I had seen enough of my advisors to move on. So I was again given this nice advice. Again, IITs, for people who don't know, is let's think of them as good research institutions in India. I was told that they do not hire faculty who did not complete their bachelor's from IITs. For 3 days, I was very sad. But fortunately, I didn't hear this particular person beyond 3 days. I didn't think of them beyond 3 days. Again, taking advice, this was perhaps done with good intentions. This was perhaps telling the average case or the most common case. This is what ChatGPT would probably do well. But I didn't fact check. Again, is that a sign of a good researcher if you don't fact check? No, right? So again, you could be a poor researcher but still be giving a keynote if you're lucky. So the important lesson for me was to fact check and don't hear everyone's advice, including mine that I'm giving you today. Now on to the post PhD work where I have been working with some excellent set of students on what we call as the sustainability lamp. We've been working on 2-3 verticals: health sensing, air quality, home energy. In the health sensing front, I see a lot of you are wearing smartwatches. I believe you use the smartwatches to track your health, fitness, etc. And you're especially keen to ensure that each and every workout is captured, right? That's what we do. We found out, and there are a couple of other studies which found out that the calorie consumption for smartwatches can be, including the top brand, let's not name them, is about 40% off. Any guesses as to why even leading watches can be that wrong when you're trying to capture your calorie consumption? Or any guesses as to what kind of things your smartwatches are measuring? How does your smartwatch capture your calorie consumption? So your watch is here. What kind of physiological signal can it get from here? The pulse, the heart rate, right? So your blood moves from your heart to the endpoints, to your fingertips. It's able to capture that path via some optical sensing, etc. And that is not enough to get your calorie consumption. What happens when you are out of breath or when you're tired, like when you're running fast? What happens? You get out of breath, your respiration rate changes. So idea was that can we instead use respiration rate in addition to your heart rate in order to measure your calorie consumption. So this is the gold standard machine which people use to measure their calorie consumption. You have to wear a mask. It's called a calorimeter. There are indirect and direct calorimeter. You have to wear these machines and you breathe in and out. So it can look at your oxygen and CO2 concentration to understand the different parameters, and then it has an internal model to live calorie consumption. Now, look at the two extremes. One is smart watches, which just use your heart rate, inaccurate. The other are indirect calorimeters. They are accurate, they can measure an O2 concentration, but you are not going to use them on your morning walk. So what we said is that there can be middle ground. We called it Joule's Eye, which can be more accurate in a smartwatch, and it can be reasonably comparable to a calorimeter. The idea was that can we sense the respiration rate? And the way we plan to do that is to use thermal sensing. So think of thermal sensors as just some additional sensors which can give you temperature information. Like your RGB camera, your thermal sensors can give you temperature information. You can put them on the handrails of your vehicle, of your cycle, or on the treadmill. So because they are looking at the temperature differences, they can look at your nostrils and they can understand the rate at which you're breathing in and out. Again, in the interest of time, I'll skip the details. We did a study with about 54 participants, and it turns out to be much more accurate than the existing smartwatches, and about 6% off with compared to an indirect calorimeter. The important lesson for us here was that we should look at the gold standard. Right? So let's look at this machine. Right? Look at what it is trying to do. It is trying to sense the oxygen concentration, the CO2 concentration. So, and it's very inconvenient, it's very expensive. And once you've understood the gold standard, then the idea is that what can you do to the gold standard to make it faster, cheaper, smaller, different kinds of metrics. And we realized that we can get the same kind of information, which is the oxygen concentration or the rate of respiration, via much more simpler medium, which is just a thermal camera. So therefore, the lesson here was that can we understand the gold standard enough so as to build the new systems. Then we went to extend this project into trying to detect sleep apnea. So I'm sure all of you have stayed with roommates who have been snoring very hard in the night, which disturbs your sleep. Not always is this due to exhaustion. Sometimes it's also due to something known as sleep apnea, where the people are not able to breathe properly. They can wake up in the middle of the night feeling breathless. This is a photo of a sleep clinic in Delhi. So it's right about 3-4 kilometers from here in a hospital called AIMS, in a sleep clinic, where a person is being sensed for sleep apnea. So they put about 30-40 odd sensors. Imagine having to sleep with this, right? Again, this is showing you the gold standard. It is measuring various kinds of things. One, it is trying to measure your nostril inhalation, exhalation. Second, it is looking at your chest inhalation, exhalation. It is looking at your brain waves. It is looking at your oxygen saturation. So again, we went to the doctors. We understood the gold standard, which is called polysomnography, and said that what can we do instead of using these gazillions of sensors. It turns out that the solution from the previous work was already with us. We wanted to now use just a thermal camera, which can accurately estimate the respiration from your nostrils as well as from your abdomen area. I'll skip the details again, and I'm happy to talk outside for more. The important lesson for me here was, and that's one of the way I've thought about this project working with the student. If we have worked well on one problem, can we now really drive home the advantage into similar areas, which was if we now know thermal sensing, we now know how to measure respiration, can we extend it to now also detect things like sleep apnea? On to the final piece of work. How many minutes do I have? 5 minutes? Okay. So the final problem, because we are in Delhi, which is the pollution capital of the world, so air pollution here kills about 7 million people every day, every year, and most of the fatalities are in India. We are looking into one very specific kind of emission source for pollution, which is known as brick kiln. So these are unorganized sectors which are used to create bricks. So any of you who have been through rural India and trains, you might have seen these chimney-like structures. Some of these chimney-like structures are sugarcane mills, which are used to create sugar. Some of them are brick kilns, which are used to create bricks. So the idea was that can we somehow estimate where these or detect where these brick kilns are, understand how many of them are violating the various environmental regulations. You might be surprised to know that the existence of these brick kilns is not only causing air pollution, it is also changing the patterns in which the rivers are flowing, which will also cause various kinds of environmental degradation. It's unfortunately also contributing significantly to modern slavery. A lot of the people working there are undereducated in very harsh, extreme conditions. So imagine us complaining of the heat waves as opposed to them working in the middle of these really hot surfaces. So we wanted to geolocate, segregate different kinds of brick kilns and also detect the compliance violation. We use computer vision and machine learning techniques on data collected via satellite imagery from both Google and Sentinel. We looked at various parts of India, like Lucknow, Delhi, West Bengal. We ended up identifying about 24,000 brick kiln sites, and we are planning to make this public in a few months. We've also created some web app for this. In terms of the compliance studies, we figured out that most of the brick kilns are violating the criteria in terms of being close to rivers, being close to hospitals, being close to other brick kilns. So the idea here was that we now didn't really have to innovate at this point of time, at this present circumstance. We've not really had to innovate in terms of the computer vision or the machine learning technology required, but we could just leverage them to solve the societal or the impactful or the sustainability problems which we had. And this was also a lesson for us so that we can also always try and stay relevant with the technologies and the tools so that we can apply them in our own community and in the problems that we want to solve. So I'll just end up by summarizing the few lessons which I'd shared, which is to test your biases. Don't assume something to be true just because your friend has told you. Choosing a lab advisor is like choosing your partner in life, so you want to be very careful about it. You want to be collecting data if you can that helps you to understand the whole process. Building some pipelines, building some baseline systems helps you understand your data better, helps you understand the metrics better. Writing and reading accessible articles helps you gain wider audience. And taking all advice, including mine today, with a grain of salt. Even well-intentioned people, because they don't know your story, they've not walked in your shoes, it might not work out for you. Creating reproducible tools goes a long way. I'm very happy that many of the communities, machine learning communities and other communities are now making reproducibility mandatory. The word impact is a very loaded term. Like, it can take time, you may get lucky and you may get impact. And it's very difficult to say what is impactful. Attend conferences nicely, at least speak to a few people who you've never spoken to. Don't just cling on to your own group. And take notes, talk to people, make connections which may last long. The process of research will involve reading, collaborating, taking notes, discussing, so that even on a failed day, you have at least learned something or something didn't work. And understanding the domain better helps a lot. So just to give more example on that, the medical study which I was talking about, we've spoken to about 5 or 6 different doctors for about 15 hours. And this collaboration which I was speaking about has taken us about 4 years to happen. There were a lot of failed collaborations earlier, but just wanted to say that for every successful collaboration, there are a few failed ones.